now. Where were we? I think we're
something to do with
doing
generator
right?
expressions.
So let's see what my notes are. There's this enclosed atom grammar, which is done. A little check that it will be that it's backported. It's backported to 315, and yeah, there are some conflicts for 314, which I don't really want to solve because these are just improvements, and the main docs will be moving to 315 pretty soon. It's probably not worth the time to solve conflicts here.
Right, right.
And we can focus on the next thing. Oh, I see Stan left some reviews. So let's see what we can have. To make it less rough, could we pass an iterator? I'm not sure what Stan means here.
See if he's around.
There's some formatting issues.
Okay.
All right. Yeah, this is not worded well. So the enclosing parentheses can be omitted in calls with only one positional argument, and Stans changes it to when it is the only argument. Which of course isn't correct either, because
that's
because
true.
it needs to be positional.
Yeah. How about saying something like when there is only one positional argument, the enclosing parentheses may be omitted.
That doesn't cover this case. There is only one positional argument.
Oh, okay. Well then, yeah. Then the way that you're writing is better. There needs to be one argument, and it must be positional. There we go.
If you do some, I don't know, if some names its arguments, no. If I do iterable equals blah blah blah. Okay, so but this when it is that is good because it also says that the generator expression needs to be that argument, right? So we probably want to keep some of that. When the like this maybe.
Yeah. Single with a
Yeah.
okay.
I mean, it's a lot of words. Can't see a good way to make it shorter. Next up. Oh yeah, this indentation is wrong. Okay, we should keep this iterator is immediately created, blah blah blah. I think that's moved further down, isn't it? now have a bunch of suggestions in the badge. Where is the button to apply the badge? That used to be here. What? Oh, here, commit suggestions. Right. Let's do that. No, the diff is unavailable for some reason. I don't think contacting support would do anything. Now the button changed into submit review. Let's do that. No conflicts. Okay, so that's where we are for the generate expressions section. And we should move on to yield, right?
Yeah.
Let's see. Okay, and that one should be based on this pull request, because it probably will have some overlap. So let's see, that's reference, expressions, and there's a conflict. There's a conflict in expressions.rst. But I don't see the conflict. I guess it was resolved already. And removed IDs, that too. Yeah. It was resolved automatically. I probably did this merge before. So let's merge it. Let's merge the main branch itself as well, just so we're starting from a good spot. So whenever the merge shows all of these news entries, that means a lot of time has passed since the last merge. So let's build the docs and see where we are. So after generator expressions, which is a nice and compact section, well, not anymore with our pull request, but at least it has more examples. There are yield expressions. So let's see how that works on docspython.org. Same URL. Okay, so this has the grammar and blah blah blah. What do we have here instead? I should probably do a diff, because I think we started on this, right? Yeah, we started on this and left halfway through for the generator expressions. So let's see what's different. Wow, there's a lot of different stuff actually. Oh, that's for the generator. Sorry. For the yield expressions only. So there's a bunch of new text and changed grammar snippets. Okay, that's okay. So this is some new text that we added previously. I guess I'm up to speed now. So the yield expression can be only used directly in a function definition block. Okay, we should probably say what the yield expressions do first, and then do the limitations, right? So using a yield expression causes the enclosing function to be a generator function. That probably needs a link somewhere. Do we have that in the glossary maybe? No? Usually refers to a generator function. Okay, we probably want to define what a generator function is. Right? Let's add this.
Oh, I see. Yeah, because we have generator. Yeah.
So, generator function is a function which returns a generator iterator. It looks like a normal function except that it contains yield expressions, blah 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 blah. And generator usually refers to a generator function, but may refer to generator iterator in some contexts. That would be a term. Right, an expression is an expression that returns an iterator. So according to this, we should probably reserve the term generator to generator functions. Let me quickly check if the generator expressions is okay in this regard. So generator iterator here. Generator function. Let's add this term. Asynchronous generator expression, is that a term? Asynchronous generator. Oh, we should probably do the same thing with asynchronous generator, right? So asynchronous generator is an asynchronous generator function.
Yeah.
And an asynchronous generator function is a function which returns an asynchronous generator iterator. Looks like a coroutine function. Is that a term for a coroutine function? Yes, there is, so it should be linked, right? Defined with async def, except that it contains yield expressions for producing a series of values usable in an async for loop. An asynchronous generator function may contain await expressions as well as async for and async with statements. Are there more async statements? I don't think so. So this needs linking. We're creating a nice maze of links from Wikipedia.
Yeah.
Alright, so should be okay here. Now we can link this. An asynchronous generator expression returns a new asynchronous generator iterator. Not an asynchronous generator object, because that's usually reserved for functions. Let's be cleared here.
Oh, I see. Wow. Okay.
Which is an asynchronous iterator? See async iterator. Let's just link that directly. And I'm changing the the section for which I already have a pull request up, which isn't great. But I think it's fine. Okay, so let's go back. This is just a lot of terms. It reads like a math textbook. The old expression can only be used directly. Oh yeah, let's get here. Using a yield expression causes the enclosing function to be a generator function. If the function is defined using async def, it becomes an asynchronous generator function. Right. I think then this is the previous text. So the old expression is used to define a generator function, blah blah blah, and thus can only be used in the body of a function definition. Yes. The old expression, let's say, can only be used in the body of a function definition. More precisely, do we have a term for block? We don't. There's probably we can make block italic. And then we can lose the note here and say here C prog structure for and for example, and just put the example here. I guess the example is what normal people would want to read.
Yeah.
Right. So if the function is blah blah blah. Makes through a generator function. Right, and I think my editor used restructured text indentation here.
Well, that's good, right?
No, because I'm writing Python code inside the
see.
restructured text,
Right.
and that means that
Right.
needs one more space.
Right.
I don't know if I'm using the wrong editor for this, but yeah, mixing restructured text and Python isn't really fun.
No, that's true.
Unless we want to change the style guide and allow for space indentation for restructured text. Wouldn't that be great?
Oh, well. Yeah.
Following a blocks module, function, body, and class definition. I think this sums it up pretty nicely. Wonder. Well, I guess the example makes things clear, but I also want this wording to stand alone. And this directly isn't really defined anywhere. So if we're saying more precisely, probably be super precise and say something like it can only be used when the closest closing block is a function definition. Not a module level or class block. See blah 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 for explanation of blocks. And this should be precise enough even for me. How does that look? enclosing function, enclosing block, and the example makes it clear. Yeah, that should work. Right, but before that, we should probably say what the yield expression does. So let's borrow some more wording from the original one. What did I do here? Oh yeah, there's a lot of stuff here. So the yield expression is blah blah, can only be used in the body of a function definition. We covered that. Causes it to be a generator function, using it blah blah blah. We covered that. This example would be good. Okay. Due to their side effects on the containing scope, yield expressions are not permitted as part of the blah blah blah. Probably want that after this example. Generator functions are described below, while asynchronous generator functions are described separately. Okay. Should generator functions also be described separately? Yeah, they should. There's this whole generator iterator. Hello? Yeah, your mic is very low, but I can hear you. Hello, hello? Can you hear me? That reminds me, I didn't really check the sound levels for the recording here. Oh, I didn't even start the stream. I'll need to upload this later. Hello, hello, can you hear me? Hello, hello, can you hear me?
Oh, I'm back. Okay, great.
Nice. Alright.
But I can't see the screen.
Ah, okay. Let's share the screen again. There we go.
Yeah, bingo. Okay, good. Thanks.
Alright, so the original text says generator functions are described below, while asynchronous generator functions are described separately in section asynchronous generator functions. Which is also below. It's right after generator iterator methods. I feel like we have some reworking to do here. Because this should not be in the syntax part of the docs.
Okay.
Maybe this at or at runtime block. At runtime, when a generator function is called, it returns an iterator known as a generator. It returns a generator iterator. That's the term. That iterator then controls the execution of the generator function. The execution starts when one of the iterator's methods is called. that time, the execution proceeds to the first yield expression. Expression where it is where execution is suspended again, returning the value of the expression after keyword to the generator's caller. If the expression is omitted, none is returned instead. Okay, now this is by suspended, and we should probably say that at the beginning or initially execution of the generator function is suspended. Here we can use it. It starts when one of the iterator's methods is called. Is that true? Can it be any of those methods? So there's next, there's send, and there's throw. Yeah. So maybe instead of one of the iterator's methods is called, I want to say something when, when the iterator is asked to produce the next value. At that time, execution proceeds to the first yield expression where yield expression, and I would now say the expression after the yield keyword is evaluated returned to the generator's caller. And execution of the generator function is suspended again. Challenge: read this once and understand it. How many times do you have to read this? The expression is omitted, none is returned instead. And I don't know if return is the correct word to use here, but I don't have anything better. Yielded maybe. So by suspended, probably want to mark this up just to link these words together. We mean that all local state is retained, including all the current bindings of local variables. The instruction pointer. Whoa, instruction pointer. Do we use instruction pointer anywhere in the docs? Do we have a term in the glossary for it? No.
I haven't seen that.
Because Python doesn't really use an instruction pointer. I think this documentation comes from the time when everybody knew assembly, or at least C, or the raw CPU APIs. So the yeah, what's a better term to use here? The place where
foreign interface?
No, the instruction pointer. So that's the place where that's the place in the function where like Python is currently. Like the next operation to do inside that function.
The stack pointer. I don't know. Next step? Cursor?
Let's look up how instruction pointer is explained on something like Wikipedia. A register that stores where a computer program is being executed. Yes. Well, let's see the currently executed instruction. Let's see, maybe in the docs we have something frame objects. Like the current line associated with the code being executed. How would I frame this? Last attempted instruction in the bytecode. So this is like the equivalent of the instruction manager. Eh. It's like the which instruction is currently being executed. The current bindings of local variables, which so I guess information about which instruction is currently being executed, or the index of the index is probably better. Being executed, the internal evaluation stack, and the state of any exception handling. Does that look good? When the execution is resumed by calling okay, let's use the previous wording here. When the iterator is asked to produce another value, the execution is resumed by calling. The function proceeds exactly as if the yield expression were, should be was. Another external call. Say any other expression. Or as if no suspension happened. How you spell that? Suspension, an interruption or temporary cessation. Right, the value of the yield expression after resuming depends on the method which resumed the execution. So I would swap this around. If send is used, or if the generator is if send is used, that's good. If send is used, then the result will be the value passed into that method. Otherwise, next is used typically via we have typically, so we probably don't need the next here. Via for loop. And the result is none. Right, looks like a good first pass, so what's next? All of this makes generator functions quite similar to coroutines. They yield multiple times, they have more than one entry point, and their execution can be suspended. The only difference is that a generator function cannot control where the execution should continue after it yields. The control is always transferred to the generator's caller. So I think this paragraph, and we touched on this before, but this paragraph was probably written before coroutines were added to Python, and it talks about a different kind of coroutines, like the ones you have in Lisp. Because current coroutines also cannot control where execution should continue. That's the job of the event loop in async IO. So I think it's best to just remove this paragraph altogether. Like, if you already know the kind of coroutines this is speaking about, you probably don't need this comparison. And if you don't, this is just misleading. So out it goes. Now, yield expressions are allowed anywhere in a try construct if the generator is not resumed before it is finalized. The generator iterator's close method will be called, allowing any pending finally clauses to execute. Okay. Sounds good.
I just switch client. There we go.
So if the generator iterator is not resumed before it is finalized, I would just say destroyed. Garbage collected. We can say its close method will be called, allowing any pending finally clauses to execute. Okay. What's next? When yield from when yield from is used, the supplied expression must be an iterable. The values produced by iterating that iterable are passed directly to the caller of the current generator's methods. caller of the current generator. Here we have a reference to the methods which we removed from earlier. That's probably new. Maybe instead of caller, we should add a new term like driver. Think about that. So any values passed in with send, any exceptions passed in with throw are passed to the underlying iterator if it has the appropriate methods. If this is not the case, then send will use attributor or typer, while throw will just raise just. Don't use just in documentation. Will raise the passed in exception immediately. When the underlying iterator is complete, the stop iteration value attribute of the raised stop iteration instance is the value of the yield expression. Let's say yield from. Here it can be either said explicitly when raising stop iteration or automatically when the sub iterator is a generator by returning a value from the sub generator. That's a lot, but it's all good information. It's a lot for this section because this is explaining how generator iterators work, and it's not even in the generator iterator like documentation section. There should probably be a generator iterator documentation section with all this information in it. Let's see if we can take this away from the syntax documentation. And that's it. So the parentheses may be omitted when the yield expression is the sole expression. There's some echo from you. Hello.
Oh, can you hear me? No.
I can hear you, but I can also hear myself with a delay. Probably piping me into your mic.
Oh, maybe I have you. Yeah, maybe I'll take a look at that. Maybe I've got something broken here.
Right, so there's PEPs, simple generators, coroutines by enhanced generators, syntax for delegating to subgenerator, asynchronous generators. Right, so we need some formal syntax here. That would be this grammar snippet. So let me rebuild the docs.
Oh, maybe this is better. I seem to have.
Let's see. Oh, I can still hear an echo.
You can still. Okay.
Yeah.
Shit.
So parentheses may be omitted when the yield expression is the sole expression on the right hand side of an assignment statement. Okay, so we have this example here. I don't know if this example is in the original docs as well. Here, so this right here is not actually a yield expression. Is it? Let's see how the actual documentation handles this. So there should be Adam, which has how does this cover yield expressions? Oh, in group there's yield expression. Okay, how does documentation cover this? So there's yield Adam, which needs to be enclosed in parentheses. So since we're in the syntax documentation, we should probably talk more about syntax right at the start and say something like for yield expressions must be enclosed in parentheses, except if they are the only expression in a statement which let's see the grammar here. Yield exper it's really yield and yield from, but there's also simple statements which have a yield statement. And a yield statement is just a yield expression. Okay.
Do we need to have a glossary entry for each one?
For each what?
I mean, for like yield expression versus yield statement?
Not really. I don't think, like,
Okay.
we have sections for them. I don't think we need glossary entries.
Oh, that's a good point. Yeah.
The own expression on the right hand side of an assignment expression. Assignment statement, sorry. Right, and this yield expression. Yeah, that should just be yield. for example, so we say define a generator that will yield and we can say yield 1, 2, 3. So this is a yield statement. An assignment statement would be something like and then we can say print second value. Right. Okay, but this is rather advanced usage of the yield expression, I would say. So normally you would use yield statements only. So if we're dealing with the simple cases first, then we should probably spend some time on this and then explain the rest. Which also means interleaving some of this wall of text and basically feeding the information in here in little chunks.
Okay, yeah.
I should probably leave asynchronous generators also down for some later section. Let's make the example like this. I don't have anything better in mind. And then we can do the runtime thing, runtime explanation. So how much of this can we put here? At runtime, when a generator function is called, it returns. Oh, so this example, this says we define a generator function. Well, let's just name a generator function. When a generator function is called, it returns a generator iterator. Let's make an example of that. Right. And then we get that iterator then controls the execution of the function. Initially, execution of the generator function is suspended. So to make the example better, we can add some print statements here. So what's my structured text indentation again? Can add some print starting line 3 or which one? 1, 2, 3, 4, 5 and ending. Iterator then controls the execution of the generator function. Initially, execution of the generator function is suspended. It starts when the iterator is asked to produce the next value. And here we can use the methods. For example, using the next function, like this. Value next generator iterator, and this will print out starting, and then when we print out first value, we get 1, 2, 3. Right, so this implicitly, like in a for loop, or explicitly, we can leave that for later. We need to get to it. And that time the execution proceeds to the first yield expression. Time the execution proceeds to the first yield expression. The blah. Compression. If the expression is omitted, none is returned instead. So let's make the example do that. Now let's make the example do that later. probably want to coin a new term. This driver is something that drives the generator that asks for the next items.
Generators. This is the code. The trigger. The client. The generator.
Client. I don't think it's better than driver.
Because the driver
is
the driver has
more
kind of an
unique.
agency. Yeah, it has. Yeah.
Yeah. It does. It controls.
Yes. Whereas this is really much more of a listener, a receiver, an audience.
No. It directly
A consumer.
asks.
Yeah.
Oh, consumer. That's good.
Consumer.
That's good. Okay, that iterator then allows control of the execution of the generator over execution of the generator function. Initially, execution, this is repeated, so let's remove that. Execution is suspended. It starts when consumer asks the iterator to produce the next value, for example, using the next function. So that would be at that time, the execution proceeds to the first yield expression. I would also say where it starts. Beginning of the defined function and the function and proceeds to the first yield expression. Function body and proceeds to the first yield expression. The expression after the yield keyword is evaluated and returned to the generator's consumer. So to the consumer. Here at the color of next. Good. Here's probably good. Execution of the generator function is execution of the generator's function is suspended again. By suspended we mean that all local state is retained, including the current bindings of local variables, index of the instruction that's currently being executed, the internal evaluation stack, and the state of any exception handling. When the iterator is asked to produce another value, the execution is resumed. The function proceeds from the yield expression where it was suspended until the next yield expression encountered. Until the I don't think we need third yield here. Like the function is returns before yield expression is encountered. Either with the return statement or implicitly at the end of the function. Next raises, or we'll say the generate raises exe is the one, right? Raises a stop iteration exception. This will give us a trace back, so let me make sure this is all correct. Starting. And we got 1, 2, 3. Generator line 4. We got this. Generator ending and a trace back. So instead of the index of the instruction that's currently being executed, maybe we can say the position where, or the yield expression at which we're suspended.
The last or
this the yield expression where it was suspended.
Yeah. Okay.
Or maybe we can say like instruction pointer. Yeah, it's a bit better. Still not perfect, but maybe in the next pass it'll be even better. Right, so if the function returns before yield expression is encountered, the generator raises a stop iteration exception. Okay, exactly as if no suspension happened. Let's leave that out. It's not entirely true anyway. So the value of the yield expression, okay, that's so we've now explained how generator iterators work in the general case. And here we should probably mention that the consumer is typically a for loop that calls next internally. So that would be for value in generator function. that should work, hopefully. Let's get the result. Okay, and so that's the basics. I would hope they're explained rather well now.
It looks so much better.
I do want to check the tutorial because we might be duplicating like generators and generator expressions in the tutorial. Oh, the tutorial starts with class-based iterators and then goes on to generators. Okay, that's not how I would have written it. But I guess it's the order in which these were added to the language.
Oh, okay.
And then we have generator expressions, of course. Okay, so this is even simpler than my explanation, which is good.
Yeah, for a tutorial, sure.
I'm not
Oh no, sorry.
too
tutorial.
happy about this adding iterator behavior to classes, but okay, well, that's the tutorial problem. I'm not working on the tutorial right now. I was just checking if this isn't already duplicated. Maybe we should say we should add some high-level overview here. Like each yield expression becomes a suspension point where control is handed over to
Oh, I like that. The generator expression or function?
The generator's we call it consumer.
Oh, that's right, consumer. Yeah, okay.
Okay, so now there are some complications and there are some restrictions. So complications are the yield. So if this expression is omitted, the yield yields none. That's an easy one. Another complication is there are the send and throw methods, which cause the yield expression to have a value. And on the syntax side, there's the related thing where you have to put parentheses around yield expressions. And another complication is the asynchronous generator functions. And then there are the restrictions. So yield expressions are allowed. Oh, I guess this is one more complication about the close method. And there's yield from. Right. And then there's value from the stop iteration. Now, limitations, the yield expression can only be used in the body of a function definition. And yield expressions are not permitted inside comprehensions and generator expressions. And I think we want to cover these in this order pretty much. But one thing I would like to do is use subsections for these. Just so they show up in the table of contents and you can search for them easier, and it has a bit more structure because we'll hopefully be adding lots of examples, just so it's easier to get all of this. So this already uses sections like generator domain methods. We'll need to move those out eventually, but we'll use this style of section, and so this will be yield without value, I guess. This will be short and sweet. I don't think we need much here. Get the none out. Maybe with the for loop it'll be better.
Yeah, that's nice. Very simple sort of comparisons.
So how would we do this? So generator iterator equals the call of the generator function, and then we would say generator iterator then we need to do next once, and after that we can call send. And this will then raise the stop iteration. I should probably point that out. maybe I want an example here. What would this do? Is it too much?
So we've got the basic, and then we've got a different value. And then what are we changing here? Oh, I see. So basically, we're saying we're contrasting next with send.
Yeah. So for this whole section, we're saying you can use send. So usually you get none. Here if you use send, you can pass a value to the yield. And maybe we can add another yield in here.
That is pretty cool, actually. To be honest, I didn't know that. Maybe it's more than just the value of the yield expression. It's different values. Results of a yield expression.
Well, this documents the value of the yield expression. Like normally it's none. So yeah,
oh, I see. Okay.
When using the basic iteration protocol for our next, the value of the yield expression is none.
Okay.
Right,
Okay.
So it's not
different value. Yeah.
And maybe we can even do a pass here.
Oh, that's cool. That's cool. It reduces the amount of text between, whatever.
Yeah.
The example and the answer.
A different value can be given by using the iterator's send method instead of for or next.
I just can't help the feeling that maybe we want a little tiny bit of text at the very beginning to sort of give people a heads up that while it's most commonly used for...
I think we...
do we do that?
It's at the end here.
Oh, okay.
But that's probably better since we're like explaining what yield actually does. Right, so this is
using a yield expression,
documentation for what yield does, not how you would define generators.
Oh, okay. I see what you're saying.
So if we wanted to explain to people how to define a function that generates values, then we would start with this and follow it by for. But if we're saying what yield does, I think it's better to start with next and basically explain the protocol, explain stop iteration, and then say for does this for you automatically. And I think this also would like a note. iterator.
We should maybe do a commit or something because it's getting towards the top of the hour.
Yeah. Okay. Okay, to do. Commit name temporary. Let me push that expressions yield branch in case anybody wants to look at it, and we'll continue next week. Thank you for your attention and your help.
Oh, excellent. Yeah.
And see you around.
Okay, cheers. Good.